Okay, Professor Hildebrandt here. I'm going to work a couple of examples from the first part of Chapter 13 on correlation analysis, and then I'll make a second video where I work problems on the second half on our regressions. So this first example is found in our textbook, Chapter 13. It's question number 4 on page 446. And I'm just going to work the last part of the question that asks you to find the correlation coefficient, which remember is designated by R. And I've written the formula down here so you guys can review that. It's formula 13.1 from the chapter, where we find that R equals the summation of the difference between our x values and our sample mean of x times our y values minus the sample mean for y. And then we divide by n minus 1, where n is our sample size, and multiply that times the standard deviation of x and the standard deviation of y. That gives us our R. So for this particular question, we're looking at the relationship between the number of assemblers that are told to work for an hour and the amount of product that they're able to produce. And so this chart is just a sampling of 5. So in this case, our n equals 5. And for the first sample that was taken, we had 2 employees working, and they were able to produce 15. Notice when we increased the number of workers to 4, production for an hour went up to 25. And then you can see the rest. 1 is 10, 5, 43 is 30. I think the best way to work out these problems are to kind of make those charts that we've used in previous chapters so that you can clearly lay out all of your information. And so that's what I've started here. If we look back in terms of x and y, remember y is always our dependent variable. So in this case, y is production, and our number of workers is our independent variable, so that will be our x values. So I've listed out our x and y values, and the first thing that we need to do is we need to calculate the mean for each of these samples. In order to do that, I'm going to sum all of our x values, and this sums up to 15. And so my x bar, since there's 15 total, and we took 5 samples, my average here, or x bar, is 3. I'm going to then do the same thing for y, and so it sums to 120. And so to find y bar, I'll take that 120 total, divide by 5, and get a sample mean for y of 24. All right, so coming up to this chart I've made, column 1, right, is our x values. And so I'm going to use that for column 3 to calculate column 3. And so it's just the value in column 1 minus the average that we just found of 3. So 2 minus 3 is negative 1. 4 minus 3 is 1. 1 minus 3 is minus 2. 5 minus 3 is 2. And 3 minus 3 is 0. And so now we're going to go down and do the same thing. So we're going to take column 2 here and use those values to calculate what would be in column 4. And now we're going to be subtracting our y sample average, which was 24. So 15 minus 24 gives us a negative 9. And then we would have 1 minus 14, 16, and 6. And then our last column is simply the product of columns 3 times 4. So that's what column 5 here is, the product of columns 3 times 4. And this is so we have the information we need to plug back into our formula 13.1 to find our R. And so negative 1 times negative 9 is 9. 1 times 1 is 1. Negative 2 times negative 14 is 28. And then we have 32. And then we have 0. And so then we're going to sum those up, and we would get a total here of 70. So now that we have that information, we can circle back around to formula 13.1. That's what we're using here for R. The book does actually ask you guys to calculate standard deviations, but when I do your Connect homework for Chapter 13, I will go in and edit those questions so that I give you the standard deviations. So for X, it's 1.581. And for our Y samples, it was 11.937. Okay, so now we're just plugging in our numbers. So we have R equals 70 in the numerator, nothing more to calculate. We've already done all those calculations. Our denominator then, n minus 1, well, remember our n was 5, so we have 5 minus 1 times the standard deviation for the sample of x, which was 1.581, and the standard deviation for our sample of y's were 11.937. And if you work out that math, we get an R here of 0.927. Okay, and so that would be the correlation coefficient, or the R, for this problem. All right, so I'm going to work now a second problem where we're given our R and we're asked to determine if there is a positive correlation or not. So this is the kind of second quarter of the chapter where it talks about testing your correlation coefficient, which, remember, the correlation coefficient is R. So this is from chapter 13, question number 38 on page 478. So this question, you have a sociologist, and they are projecting that they believe there's a relationship between a student's success in college, measured by their GPA, and their family's level of income. And so we're given that a sample of 20 students was selected. The R was found to be 0.40, and then we're asked to figure out whether or not there is a positive correlation. And we're told in this question to use a 0.01 level of significance. Okay, so our first step then is going to be to state our null and our alternate hypothesis. So our null hypothesis, remember we use this symbol we call rho, is that it's less than or equal to 0. And so then the alternate is that it is actually greater than 0. For our second step, we need to find our critical value so that we can come up with our decision statement. And this is where we're going to go to our textbook and use Appendix B5. This is a one-tailed test, okay, because it's greater than or less than. So we're looking at a one-tailed test. So you go to the column for one-tailed test. Remember, our significance level was 0.01. And we'll go down. For your degrees of freedom on these problems, the degrees of freedom that you're going to use is n minus 2. And remember, we were told our sample here was 20, so 20 minus 2, or 18, is going to be the degrees of freedom. And if you go down, what we would find is a t-value of 2.552. So that's our critical value. So we are going to reject the null hypothesis if the t statistic that we get for the problem is greater than 2.552. Okay? All right, so sorry. So now we're going to use formula step 3. We're going to now be using formula 13.2 from the text, where we find our t-value, and it's r times the square root of n minus 2 divided by the square root of 1 minus r squared. So this is the formula that I'm going to use now to calculate the t-value for this problem. So we have t equals, okay, well, our r we were told was 0.4. Again, my sample size was 20, so 20 minus 2. And then divide by the square root of 1 minus that 0.4 squared. So we'll have 0.4 times the square root of 18. And then we'll have that divided by the square root of 1 minus 0.16. So this becomes 0.4 times 4.243 divided by the square root of 1 minus, I already said this one, hold on, let me back it up. Divided by the square root of 0.84. So let me copy this equation over because I've run out of space. So t equals 0.4 times 4.243 divided by the square root of 0.84. So in my numerator, I would have 1.6972, and my denominator then is 0.917, and so my t value is 1.851. And recall our decision statement, we were going to reject if our t was greater than 2.552, which in this case it is not. So my conclusion is we do not reject the null hypothesis. What does this mean? Well, it means that we cannot conclude that there is a positive correlation between our two variables here, and so in this case between a student's GPA as a measure of success and their family's level of income. All right, I hope this helps you with the correlation analysis and our R coefficient. Again, be looking for another video shortly that does our regression analysis.